Hey, good morning, everyone. I am Bruno Turkley, and next to me is my buddy and colleague, Brett Statham.
Evening, morning, wherever you are.
We are excited to be here. We're here to talk to you about web services and Windows Azure. Very important technologies of the future. And so we have a lot of good content today. So in the spirit of keeping good time, I'm just going to start right into this. A little about myself. I'm a columnist in MSDN Magazine. A couple years now, my friend and I, Ricardo Villalobos, we write about Azure quite a bit. I've been focused on Azure since launch a few years ago. I have a meetup in San Francisco where I'm from. Do a lot of talks in the Valley about different technologies. I blog a lot, so in fact, everything I talk about today, for the most part, is on my blog. So feel free to go there and get the heads up on everything I'm doing. So I'm going to pass it over to my colleague here.
Thank you, Bruno. As Bruno said, my name's Brett. I'm on Bruno's team, and that was actually a really cool thing for me when I came on board at Microsoft. I'd met Bruno a couple of times at code camps and things like that, and so honored to be sitting here with Bruno today. You can find me on the web. I'm up there at brettstatham.com, and just this morning I posted a page with a download link to the demo files and that kind of stuff that I have done so far. There's some I have to clean up a little bit, and so I'll be updating that post. You can grab them from there as well. But anyhow, I've been working on Microsoft technologies really my whole professional career, and specific to today, sort of related around web and .NET and data and all that kind of stuff. I started developing webs on Windows NT 3.5. And before IIS existed and all that good stuff, I was one of the earlier developers that got to go around to do the .NET Roadshow training. So I've been doing .NET since before .NET, and then I would say my favorite SQL Server product Microsoft product is SQL Server. So the slide says I'm in love with SQL Server, but please don't tell my wife. So.
Well, we have a similar background. Both of us were professional trainers for years, decades. We traveled the globe doing this stuff. So this is really natural and fun for us.
Yeah, indeed.
So yeah, I wish I hadn't spoken to your wife this morning. I don't see. So it's okay. It's okay, Brett. The SQL team likes that.
Yep.
So we've got a bunch of interesting modules here, 7 of them. And we're kind of trying to balance it all out. Some of the modules might go longer than others. Some of them might be brief, but we'll just do our best here and jump right in. So you can see we'll kick it off with WCF services, kind of an overview. What is that all about? We'll get into hosting them in Azure, which is, how would you describe Azure, Brett?
Well, just going back to WCF services, WCF services gave you a way to host your server-side logic really in any environment. And that's one of the cool things about Azure is actually a multi-environment platform. We have web, but we also have just core compute type where I can go run executables on virtual machines or classes running as services and all that kind of stuff. And so in that module, we'll talk through some of the different ways that you can take a great WCF service that can really be hosted in really pretty much any .NET managed environment and look at how you can do it with websites and web roles and worker roles and all that good stuff.
And for those of you living in a cave, Azure is the Microsoft cloud. So it's a big platform, successful platform. We have a lot to say about that as the day moves on. So this module 3 makes Brett's wife a little bit jealous. It's about data. And that'll be interesting because we'll talk not just about the database world in terms of data, but also Azure and some of the abstractions we have there for tables, blobs, and queues. And then from there, Brett's going to jump into data access, and you're going to get into what, ADO?
Yeah, well, you can't talk about data access without, giving homage back to just good old ADO.NET. And ADO.NET's not gone. It's still there. In fact, it's a foundation to most of the other data technologies that you should use from .NET other than just pure HTTP services. So we'll talk about ADO.NET and sort of look at that core foundation. Then we'll come back and talk about Link as a great way to query data in memory. But then also a lot of the data that we work with comes in XML format. So we'll talk about processing XML using good old DOM stuff, but also using Link to process XML.
I think everyone should know LINQ, Language Integrated
man.
Query. You can query XML objects, databases, objects in your C# or VB code.
Yep.
It's an awesome, but Entity Framework, my friend says I should do stored procedures with SQL Server. Why Entity Framework?
Well, Entity Framework takes a lot. In fact, as I go through and look at data access, you'll see a lot of that low-level code that was really repetitive. And I can't tell you how many times, going back to ADO, predecessor to ADO.NET, how many times I wrote code to loop through a result set or a record set or something like that, and simply produce the output. Entity Framework sort of gave us a way to turn that data access, that tedious, relational, very SQL-based sort of data access, and turn it into a way for us to just treat them like objects and collections. And once I have data in a collection, I can run LINQ on it. And so it makes it really easy for me to, as a programmer, interact with that data. And I let the Entity Framework models do the mapping to the database engines for me behind the scenes. So I get away from select star froms and putting SQL statements in quotes and parameterizing them and all that good stuff, and we let Entity Framework do that for us.
I'm a developer. I like working with objects, so having to deal with joins and all that stuff, it's kind of a distraction. I think the cool thing about Entity Frameworks, it figures out the relationships and then creates your object model almost automatically.
Yep.
I hear a lot of stuff about RESTful services, and I think your module here, Web API, gets into that a little bit.
Yep. So with WCF was fantastic because it took a lot of the disparate programming models that we had for distributed computing and sort of pulled them together into one sort of umbrella. But with all of the sort of evolution of modern applications and mobile devices and all that kind of stuff, the SOAP-based protocol that WCF sort of relies on is a little bit heavy and a little bit unwieldy for some of those smaller devices or distributed programming models and all that kind of stuff to use. So the industry has really sort of had this move back to just using good old HTTP.
And we'll debate that, the whole REST versus SOAP parameter. A lot of people say, hey, give SOAP a rest, pun intended.
Yeah.
And then in this final module, Advanced WCF Topics, I mean, you could go on for days in this particular area. We'll talk about maybe some stuff like programmatically hosting and consuming a WCF service without any configuration files. In addition, in that module, we'll talk a little bit about the service bus, which allows for kind of disconnected, kind of occasionally connected scenarios. So that should be interesting as well, Module 7. So expectations, we assume that you know about code. We'll be coding in C# for the most part. But really, language doesn't matter. It's about knowing the framework. So we think you'll be able to follow along pretty well. We'll try to explain things. Anything else we want to say on this particular screen, Brett?
Yeah, the particular slide is not the right slide, so sorry about that. That was apparently a copy-paste issue. Is the next one the right one? Nope. So anyhow, it's not, go back a slide for me. Yeah, it's not the 7488, it's the 7487 exam, which the topics that we discussed today are topics that are addressed on the exam. This is in no way, though, of course, that's going to prep you for that exam. Right. So you still need to go back and study these at a deeper level if you do intend to take those. And one of the great ways to do that is through a Microsoft Learning Partner, going out and taking our Microsoft official course, which is the 2487 course. So feel free to look up a partner in your area and think about taking that course as well.
So just to be clear, it's 487, right?
Right. So 70-487 for the exam and 2487 for the official course number. So that was apparently a copy-paste issue on my part there.
All right, excellent. 7487, great. So I do think this stuff is really relevant, though, for a developer today. Even though it's not everything for the exam, I think it's kind of, you and I have been in the real world a while, so I think a lot of what we talk about is pretty useful.
Cool. Yeah, and of course, this is being put on by Microsoft Virtual Academy, and a lot of great learning opportunities on MVA. But along with that, there's also Earn As You Learn sort of programs. And so if you are looking at doing that, there's a URL on the screen there for the aka.ms MVA-voucher. And the code that you want for this course that is not the right code, and that's not the right expiration date. So I will get you those right values, and we'll put them up at a later time. So again, that's back to my copy-paste error. I don't know what happened to the right slides. We fixed them. They're not there.
Today is the 13th, by the way.
That's true.
So there might be some weird stuff happening.
We'll post those, or perhaps they can post them into the chat window for you as well.
But you can earn 50 points today with MVS.
Yes, yes.
So
when you get the right voucher code, which
minor
eventually
detail.
we'll get to you.
All right, awesome. So let's jump right in here to some of the stuff. One of the first things we'll do is kind of give you the overview of WCF. And from there, we'll kind of go over some of the other material. So let's just jump into some of the stuff. What is WCF? It's a runtime and a set of APIs that lets you create web services for kind of service-oriented applications, stuff that has a server-side back-end.
Those aren't your right slides.
Well, let's go with what we have for the moment.
Right. Cool.
So, common task for a web service. What's the whole purpose of a WCF service? Well, a lot of times it's to abstract away the database. Typically from an app, you can't directly access the database from a client application. So the web service acts kind of like a broker or a proxy to the underlying database.
Sure, yep.
So typically, web services communicate with each other, and so it's a way to do what they call service-oriented architectures. You hear a lot about this. Architects talk about abstracting away business rules and database operations by basically orchestrating a number of web services. And finally, you're trying to provide good feedback to a client request and kind of broker that asynchronous call, so that the client can continue to operate while that operation executes on the back end. Here's like a typical scenario you might have. If you notice at the top over here, we've got a web service and a client user interface that typically ends up calling into our service, which is this little section over here. And from there, that service might make the call to the database, and then ultimately the data bounces all the way back to the client. So that's a typical web service scenario. So SOAP. SOAP, how would you explain SOAP here? Is it something I'm going to bathe with, Brett?
Well, I hope you do, but maybe not the same soap. Yeah, SOAP was really, if you go back and think about before we had formal web services. In fact, that was one of the things I loved about .NET, was just good old ASMX web services and this ability to build distributed applications across firewall boundaries and all that kind of stuff. But XML web services, which ASMX and ASP.NET web services were, sort of needed this agreement of how are the client and the server going to communicate with each other. And that's really what SOAP was. But it got pretty heavy, but man, did it work. Right?
And it's still pretty much many businesses, enterprises globally, SOAP is not going away.
Yeah,
it solves problems that REST can, and we'll get into that in a little bit.
Still a lot of great uses for using SOAP and getting into the WS stars and all that kind of stuff around that.
Part of the challenge is that it's an XML format, and so by being an XML format, it's kind of heavy, it's wordy. We'll learn a little bit more about JSON later today. So let's actually debate SOAP versus REST. What is REST? It's, well, I don't know if this even helps you, representational state transfer. Kind of a funny term. It came out of a paper out of Roy Fielding. And so this is all the way back in year 2000. He did his PhD on this. And so it's an architectural style is one way to explain this. The advantages, well, it's pretty much efficient and light. And that's, I think, the main kind of stumbling block that SOAP faced. It wasn't kind of efficient enough. Now, security, some people debate about this. It does support HTTPS. SOAP goes a lot farther in terms of security and all the different kind of paradigms it supports. REST is modern. A lot of kind of Web 2.0 companies are embracing SOAP. And the nice thing about it, there's no toolkits or anything that you need to really, it's just HTTP and data coming across the wire. And so pretty much anyone that can talk HTTP can talk REST. And part of what REST returns, typically it's JSON-based data. JavaScript object notation. It's basically a leaner, meaner way to represent data as compared to XML. So I think that's one of the main advantages. Now, SOAP has a lot of interesting stuff. One of them is, for example, all these different bindings that it supports. So if you notice here, I'm not going to read them all to you, but let's say you want federated identity. Let's say you want just straight HTTP, or you want to do a TCP connection. SOAP supports all these interesting protocols that that Restus does not.
Yeah.
So,
and that, for me, again, you go back and you look at when WCF came out. Before that WCF umbrella, we had .NET remoting, and then you had distributed comm and enterprise services and all that kind of stuff. And so, as somebody who needed to build, we were supposed to be doing in-tier development and all that good stuff. You had this problem of what was the right way to go about doing it, and not only what was the right way, though, you still have to answer those questions because there are different, transports and things like that. But you did them all differently. And I do this, I do .NET remoting differently than I would do DCOM, different, et cetera. And so WCF gave us this, common programming model over all of those different sort of ideas, and gave us a consistent way to do it. And these bindings, of being able to say, hey, look, let's just take this service and host it over .NET. TCP, or let's host it over, HTTP or over message queues or, whatever. So it was really cool to be able to have that common programming model, irrespective of the transport, the security mode, all that good stuff.
Agreed. One thing for sure, though, the client pretty much has to agree with the server what that protocol is and all the various other parameters that can vary between the two.
Definitely.
So what I'd like to do is maybe just create a little brief WCF service, run it for you all, and see, take a look at how that might look to you. I'm going to fire up Visual Studio here. I'm running 2013, and I'm going to go over to the File menu and say File, New Project. And if you notice, one of the options here is WCF. And so we're going to just give this thing a name. We're going to call this Flip Case Service. And when I do that, it's going to essentially bring up the WCF service library template. That's the one we're going to use here today. And I'm going to click OK. Let me make sure I have the right language. I'm doing it in C#, doing WCF, service library. It looks good here. Click OK. So I'm going to just put this in a different folder that doesn't have that already. So it's actually ready to run as it is. It kind of fills in a lot of what we're going to do eventually to fill this thing in. It's got an app config. It's got an interface file. We'll talk more about that in a moment. So we're just going to kind of build this out, and then from there we're going to explain some of the things we did with our PowerPoint. So one of the first things I want to do is maybe rename this interface. So I'm going to right mouse click on this interface file and rename it. I'm going to call it iflipcaseservice.cs. I'm also going to rename the implementation file of that interface to flipcaseservice. And start kind of programming this guy in a little bit here. One of the things you'll notice here is that it will compile right out of the box here, even just rename some things. And if I run it, it'll bring up the WCF client testing tool. And so I can go in here and actually start playing with this thing. I can sit here and invoke it and get some results. So that's kind of interesting. I'm going to quit out of this and kind of develop this a little bit. This will be an example we work with throughout today's module. So I'm going to kind of get rid of all this code over here and paste in a little bit code here. And what we're going to do basically is pass in a data structure that has a string in it. The service is going to take in from the client that string in that data structure and flip the case out of it. So that kind of demonstrates how you pass information into the service and get information back out. So I'm going to show you the implementation file of that right now here. And again, this is all on my blog, all this code. Here you can see the code. We still need this data structure, and we'll talk about data contracts and the like. So I'm going to go over here and add a new class. I'm going to add a string data object. And I'm going to paste in the code here for that. And notice the structure is very simple. I'm going to pass in a string, the original string, and I'm going to get back a string that's been converted and flipped in case. And you can see that happening in this loop here. Notice the method I'm going to call is flip the case. I'm going to pass in the data structure. It's going to loop through that data structure, and depending on whether the existing character is uppercase or lowercase, it'll switch it.
Cool. Hey, can you zoom in a little bit on that?
Sure.
Can you actually make your font just a little larger, just overall?
Sure. So here's that little loop. Notice it's going to get in the data structure. It's going to loop through the original string, one character at a time, and it's going to toggle it with this code right here. Make sense?
Yep.
Okay, so I can run it as is right now. Let's see how it works out. I'm going to compile, go to the build menu, build a solution. I'm going to hit the F5 or the start key here. And you'll see the WCF test client fire up. And you can see here it has my method. So I can actually double click on this here and type in, say, my name to the original string, and I can hit the invoke method, and it's going to basically convert it, as you can see right here. So it took my original string, Bruno Turkley, and just flipped the case.
Very cool. If you think of that WCF test client, that's something that was written by the Visual Studio team or the WCF team. They don't know what flip case service is, so that's one of those cool things about WCF services is that they're discoverable. A client application can walk up to the service and say, "Hey, what do you do? And how do I talk to you?" and just figure it out. And so that's all that WCF test client's doing. That's really cool.
And actually, if you look at the configuration file, that's where some of this is controlled here. So if I kind of drill down into this file, this is kind of the heart and soul of WCF, is what happens in this configuration file. And what you're referring to, Brett, is this notion of a service metadata. So this is what allows a client to say, hey, what are the methods and properties of the object of the service that I want to communicate with? And if you recall, we had a number of protocols that WCF supports. So what you could do over here is, you notice we have one endpoint with basic HTTP binding. What we can do is paste in our own endpoints. Let's say we want to support much more than just that. So I can go ahead here now and add some more endpoints. So notice now I've got
you type fast.
I am, yeah. I had a couple cups of coffee this morning. Notice I have WS HTTP binding. I have basic HTTP binding and net TCP. We're going to talk about this. We're going to go back to the deck and talk a little bit about all those bindings in a moment. I can also go in here below services and add service behaviors to some of these bindings. So for example, right over here, we're saying no security for the WS HTTP, and that was up here. So no security for this one over here, the binding configuration WS, that's the name of it. So now we've got 3 endpoints, which means what exactly? We have 3 different entry points into the service that a client could exercise depending on how that client wanted to communicate.
Yeah, if you think about that, again, you wrote the service. You didn't change the service at all. What the service does is flip case. That didn't change. All you were doing is through configuration, opening up sort of the doorways that client applications could use to get to that service. And if you think about it, you did all of that in the app.config file, which isn't even part of the source code. So that's something an administrator could do.
Exactly.
Right? Or I could deploy that to a completely other environment and totally rewire those endpoints based on the conditions that the service is running it. So that's really cool.
And the client, when it connects to the service, is going to need to know all those endpoints and all those protocols, and that's what we're going to talk a little bit about in the PowerPoint deck. So let's run this one again, and here we'll see now that there'll be 3 endpoints in the client. So if you notice over here, I've got all my different endpoints here and they all work. TCP, for example, is a real fast one. So I could just go in here and type in my name here and get it through TCP. In the future, do not show this. That sounds like a good idea. So you can see that indeed, regardless of the endpoint I choose, they all do pretty much the same task.
Right.
They all flip the case. I get to choose the protocol that I want to use, however. So Brett, let's return back to the deck and kind of talk a little bit more about what WCF can do. So for example, data contracts. If you recall, we just did a data contract. In fact, let's flip to that. So what is exactly a data contract? It's just a formal agreement between client and service on how data will be structured across the wire. It's how it's going to be exchanged. And so basically the client and the service need to agree on this format if they're going to communicate with one another. So ultimately, the data is going to be serialized in XML and unserialized on the client. And here's an example of what we added to our project. Notice we've decorated this thing. What do they mean by decoration, Brett?
Attributes, right? So we can go in and we're really telling the compiler something about the structures that we're building in there. And so by going in and marking something as a data contract or as a service contract or an operation contract or whatever, we're letting that compiler know that it needs to go in and wire up the right pieces, or if not the compiler, the runtime. The runtime can then look at that service and go, oh, hey, I need to sort of provide these additional functionalities around your code out there. Serialization and all that good stuff.
So just by putting this kind of attribute, if you will, on either the class and or the data members, the developer doesn't need to worry about kind of serializing this in a different format and transmitting across the wire. This attribute tells the whole runtime system, hey, can you do this for me? This is the data I want to transmit. So if I had omitted that one below data member, that would have never been passed along or communicated back. Okay, great. So configuring it, we're going to talk about interfaces a little bit, interface-based programming. If you recall, back in our project over here, we have an interface file. And notice the interface file is just a signature of what the real method does. And so what is the advantage? Why do we do interfaces? Frankly, this has been around for many, many years, this kind of concept. It wasn't invented by WCF. So here you can see that it's been decorated. So this simply means that when a client connects and communicates with the service, these are the parameters, this are the return values, this is the class, and so on that it's going to talk with. So why use interfaces? Well, it's popular for a reason. One of the reasons is it allows for reusability, maintainability, it's extensible. And basically the client doesn't really need to know the whole class. It just needs to know, what's the interface, what's the parameters, what are the methods I call. And so I can add more and more interfaces to a class depending on the client. For example, a manager might interact with a service in a different way than a customer. That manager would use a different interface as compared to a customer. Typically, and we'll see this later today in the last module, you separate this into a different assembly normally. That way it's stored centrally so the client can see the interface and the server. So if you were developing a client and service backend, you'd probably make the interface in a separate assembly, a separate project in Visual Studio to basically increase the ability to share it.
Yeah, I mean, it just expands sort of the ways that a client can learn about your service. If they can talk directly to your assembly that has your interfaces in it, they don't need that service metadata.
Exactly.
Or at least not for the contract part. They maybe need it for the endpoints, but not for the contract. So having those interfaces there and being able to distribute them and reuse them is cool.
So the point is that the client doesn't even need to know what inside the method call work. They just need to know the interface, the way it communicates with that service. And that's what the interface basically defines. So here my last point on this screen is that typically you'll implement many interfaces depending on the type of client. So like I said, a manager will have a different interface than a regular customer. So we're just going to kind of show you here that all those different endpoints share the same interface. Why use? Well, again, it just simplifies programming. You mark these things. You can see here there's a service contract and an operation contract. And you won't see this in the implementation of the flip case service. So if I toggle back to the code over here, you'll notice that these attributes are right here on the interface, But when I go into the class itself here, notice that it does, in fact, inherit from the interface, but none of those distracting attributes are here. They were all defined in the interface. So as a developer, I like it because it makes my implementation file nice and clean.
Yeah, and in fact, if you looked at that class for string data, there's or for your service implementation, there's nothing that says you can be directly interacting with those classes within the same assembly, right? Without going through the service.
Exactly.
Yeah, so the attributes can just kind of fall back through the contract layer when you do it that way.
Now recall, that's a good point, Brett. If you recall a moment ago, we added a bunch of endpoints here to my app config. Let's talk a little bit about our ABCs here. Notice we have an address, A, binding, B, and C, contract. The contract is just the interface, essentially, for this endpoint. Now, obviously, each endpoint could have a different interface. They could share the same interface as they are in this particular case. But you could provide different endpoints with different interfaces. So we want to learn a little bit more about this concept of an endpoint and the ABCs that are behind it. So an endpoint is just a way, and in our case, our WCF service has 3 endpoints. That's why you see the 3 green circles. So there's 3 ways the client can actually connect. Now, it's basically these endpoints are the gateway to the functionality of the service, and that's why we have these endpoints to begin with. So we go to the ABCs. The address is, of course, where the client is going to connect to. The binding is basically how the client connects, and there's a lot of information about bindings. There's a whole bunch of slides coming up about that. The security, the transport, and so on, the encoding that we're going to choose. And the contract, of course, is that interface we just talked about, the methods that it can communicate with in that service. And of course, there'll be a set of behaviors. One of them, for example, is the metadata. Right. And you can add other ones about security and discoverability.
Transactions.
Yeah,
the way I always think of the ABCs, I think about it from a client perspective, right? A service is useless if nobody's using it. Services are about clients, right, coming in and consuming them. And so if I'm hosting a service and I want a client to use me, that client needs to know where I am, how to talk to me, and what the heck I'm going to do for them, right? So that's the address is where am I, how do they talk to me, that's the binding, and what the heck am I going to do for them, that's the contract, right? And so if you think about it that way, it really just sort of makes sense. Well, of course I need those 3 things. And all of them have to be in place somehow. In order for the client service to effectively communicate.
And as you learn more about the ABCs, that's really where you learn about WCF, because that's the way you configure the system. So here's an example of what we just did. We had 3 endpoints. Notice, for example, over here, we have a binding here for WS binding. We have a binding here with basic binding. And we have a binding here with TCP binding. And notice the addresses differ for each one of these. So, for example, if we want to get to the WS binding, we go to this particular address. And if we want basic binding, we go to this address, so on and so forth. Notice TCP is a little bit different, of course. Notice as well that the contracts are all the same in this case. So we decided we're just going to have the same exact contracts, but they could be different. You don't have to have the same contracts for all the endpoints. Okay, bindings. What should you know about bindings? Well, there's 3 main categories: the transport that's being used, the encoding, and the protocol details. And the client, of course, needs to know that plus the ABCs. So we're going to go take a look at some of that, the bindings in detail here. So remember, there's the ABCs, the address, the binding, the contract, and these are the things you want to know about: the transport, the encoding, and the protocol details. And so when you talk about the transport, that's basically how the information travels from endpoint to endpoint. And so we have here HTTP, we have TCP, we have message queuing, and we have named pipes. So let's take a little deeper look at each one of those and see kind of what the trade-offs, advantages are, maybe use case scenarios for some of these. HTTP is your typical request response pattern, and I think the advantage of that guy is that it's interoperable with non-WCF clients. So this would mean any client capable of HTTP, even other platforms and environments, Java, PHP, could communicate with this type of a back end. The challenge is that HTTP is stateless. So it's up to the developer as they navigate between calls to try to maintain state somehow. Now TCP is another transport protocol that you can use, and that has a lot of advantages, one of which is speed, very fast. The other advantages is that it can kind of navigate through routers, and it can go behind network translation, address translation layers. It can deal with duplicate packets. It has a lot of capabilities, very popular protocol in the web service world. When you talk about duplex, and that simply means that it allows for client and server to communicate back and forth and kind of keep track of the order of messages. So that's the advantage of TCP. Named pipes, that's typically when one WCF service communicates with another WCF service on the same machine. It leverages shared memory, so it's really efficient. Message queuing, we'll talk a little bit about queuing. Think of a queue as a temporary location. You might have scenarios where the client is occasionally not connected. And what if the service wants to send a message to a client when the client's not connected? It puts it in the queue. And what happens later? The client connects up. It says, hey, there's messages in the queue. In fact, this is a kind of something that we support in Windows Azure in a variety of ways. A very important kind of technology in today's occasionally connected world.
Definitely.
Okay, so encoding is part 2 of a binding, and you can choose between 3 options. How is that data structured? Is it text? Is it binary? Is it MTOM? Well, text is pretty obvious, just text across the wire, but it's slow, it's bigger. Binary is fast, it's very efficient, it's in binary format. However, if you're sending large messages, you want to go to MTOM, which is the message transmission, wow, what a mouthful, optimization mechanism. It's if you want to send large amounts of binary data and you want to minimize the kind of payload as much as possible. It doesn't do any of this base 64 encoding, which adds size. And so those are the kind of different encodings you can choose. My guess is you'll want to choose binary most of the time unless you're transmitting super large amounts of data, like big movies or pictures. MTOM would be appropriate.
You know, and actually, as you think of the encodings, that kind of gets you back into that, SOAP versus REST argument too. And WCF can do XML, and it can do binary, and it can do JSON, if you want to make it do it. And same thing with REST. REST can return data different ways, but we tend to think of sort of SOAP services being very XML oriented, at least from a text perspective, and REST services being more so JSON oriented. And JSON, probably from a verbosity perspective, is a lot lighter weight than XML for that. So, yeah.
Correct. Yep. And so the kind of counter argument to some of that is that SOAP has that SOAP envelope, and depending on your payload size, that SOAP envelope might be proportionately large relative to the payload. Whereas with REST, you might be able to bypass that envelope and just really send just the data.
Yeah, or just even think of MSMQ. Having that SOAP envelope and being able to sort of wrap this metadata around your message makes things like MSMQ transports, viable.
Exactly. Okay, let's move on here. Protocol, the third part of a binding, and that's basically kind of how the data is structured across the wire. XML is the format, and so we're kind of talking about SOAP here for the most part. Again, the disadvantage is that XML format can be slow, even if it is in binary format. And so I think the other key aspect that differentiates REST from SOAP is this notion of the WS star standard. There's a lot of specifications. I'm not going to read all these to you, but notice there's a lot of them. For example, federated identity, reliable messaging, so you're guaranteed that the client and server get their messages. There's a lot of scenarios where REST just can't measure up to this. Transactions, for example. SOAP is just so much more powerful because it supports all these different specifications that in some cases it's your only option if that's what you need. It makes no sense to try to replicate this in REST if you can just leverage it out of SOAP. So one of the things we want to talk about is how does the client consume a service? Now the client app can be virtually anything in the Microsoft world, whether it's a console app, a WPF app, a WinForm app. Obviously if you use HTTP binding, you can open up that list to different clients, but let's take a quick look at how you might consume a service like this one by building up a client.
Wait, you mean everybody's not just going to use WCF Test Client?
Yeah, that's kind of a challenge. We haven't talked really about hosting it yet, right?
Yeah.
Because Test Client brings it up so it can be called, but we'll cover that in a little bit. Let's go ahead back to our project now and basically add a client application here. So we're going to right mouse click here and say add a new project. We're going to choose a console application over here. And we'll just call this console client. One of the first things we want to do here is set some service references, like the service model and so on here, but some of that can be done automatically. Now what's kind of interesting here is the client, because it's sharing the same project over here with the server, we can actually go in here and say right mouse click on a reference and say add a service reference. Now if I say discover over here, it's going to actually find my service. And I can give this namespace a name like WCF, for example.
Now, it was finding it because it's in the same solution.
Exactly.
Right.
Later, we'll look at mechanisms where I can actually call a utility to generate the necessary information to connect. So at this stage, what it's doing is it's basically adding some references. Notice system service model is a big one for WCF, and so is system runtime serialization. These are two kind of assemblies that make WCF work its magic. So now we can actually go ahead and create some of the client code over here to do the connection. Let's paste that in real briefly. And you can see here that it's doing the call. I'm going to add some of my using statements. I'm going to say control period, and it's going to basically add the references that I need here. So notice that it automatically now, because that service reference has these types built in, like even our custom data type of string data, it's ready to go.
Hey, zoom in again on that.
Let me make a little bit of room here for everybody. So notice we're going to lock into basic HTTP binding. And remember, the config file got updated here. So how does it know what that is? It was all added here when we added the service reference. Notice the client was able to discover all the different protocols that connect to my service. It also has track of all the ABCs of my endpoints on this. So it's almost like a duplicate of what's on the service side, which is really what you want at the end of the day. So here we're going to just connect with basic binding. I could have connected with TCP or WS binding. We're going to build up a string data object. We're going to load it up with a case that we want to flip. We're going to call the flip case. It's going to return back the result, and we're going to display the result over here. So what I need to do is kind of fire up the service backend. So I'm going to right mouse click on the service, make sure it's up and running. We'll talk about how you would host it in the future. But I do need it to be running so the client can call into it. So I'm going to go back to the Solution Explorer. I'm going to put a little breakpoint here so we can actually see things happening. Maybe I ought to compile too. Why not? Let me compile the client just to make sure everything's good. Let me stop debugging. Yeah, it looks good. I'm going to now start up the service again because I did a compilation. So I'm going to go run the debugger. Basically, it brings up the WCF test client when I do that. When it comes up, you know things are working correctly for the most part. No guarantees. I'm going to right mouse click on console client and run that one now. And you can see I'm now debugging this thing. I'm going to hit the F10 key. I'm going to basically instantiate a string data object and pass in the original string. So if I go over here, right mouse click and say quick watch, you'll see that I have half of it filled out. I have the original case here, Bruno, but it hasn't really filled in flip case yet. Well, that's about to happen on this very next call. So I'm going to basically hit F10 one more time, and it just flipped it. And then it's going to write the result to the screen, to the console. So if I toggle here to the bottom and look at the console, indeed, the flip worked. I can see that my case has been flipped. So this is an example of the client connecting up and consuming this web service. Let's return back to the deck here. Let me stop running real quickly. Close things up, close up the test client. So we just kind of demonstrated that a little bit. Now let's talk about hosting a service. Now, there are kind of three ways to do this. One's in IIS, one of them is in a Windows service, and one of them is in a managed app, which we'll demonstrate that last one momentarily. Let's talk about those three options and when it makes most sense to use those. Now, hosting in IIS has a lot of built-in functionality. What comes to your mind, Brett, when you think about IIS?
Well, certainly, if you think about HTTP in general and just sort of the availability of web sites to anybody with a browser, that kind of makes your service just available to anybody out there, within the reach of your IIS server to be able to just go consume that service. I don't have to figure out how to host it. I just kind of stick the service on my web server, and it's up there, and my clients can come grab it. So.
Yeah, for example, IIS has built-in functionality to kind of recycle your process if memory is low. It does some health monitoring. It's just got a lot of built-in deployment options. So it's a very effective way to host your service. Option 2 is within almost the operating system. It's the Windows service. The advantage of this, it's broadly supported. It starts up automatically every single time when your system boots up. And you can kind of control its lifetime with the Service Control Manager. This is the other option, option 2. Option 3, we're going to kind of demonstrate here in a moment. Option 3 is probably the most flexible. It requires the least infrastructure to deploy, but it's kind of the least robust. You kind of have to keep an eye on the lifetime of it, make sure it's up and running, and verify that it's functioning correctly. So managed applications do not provide a lot of the stuff built in to IIS, for example. So let's talk briefly how you might host this application in a managed application. So I'm going to go back to my project. I think this will be the last demo for this section. So I'm going to go over here and say add, new project, WPF app. And again, I could have chosen console. I could have chosen a variety of places. You even notice here we even have a Windows service if you want. So I'll just call this WPF host. Click OK. Now one of the things we're going to want to do is set some references right off the bat. So if we go over here, my WPF app knows nothing essentially about the underlying WCF goal we have. So I'm going to right mouse click, add a reference. One of the cool things here is I can go up into the search bar and kind of just search for what I'm looking for. And I'm looking for the service model. I'm also looking to connect up to that service we already created. After all, that's the thing I want to host. I need to set a reference to it. So at this point, we've got our references. You can verify them here, service model, and you can see the flip case service.
Yeah, and that service model is pretty much where WCF lives.
Yeah.
I mean, there's a few assemblies around that, serialization and a few other things, but system.service model, that's sort of WCF's home.
It is. What we're going to do next here is basically add a little button here to say, hey, host the service. So I'm going to go and drag a button over here to our user interface here and expand this out. And I'll just say this thing will say host WCF. Let's make the font size a little bigger for our friends out there. And let's give it an event procedure. Let's say on the click event, we will go to button _ click. And that's it. So now we're going to write some code for this thing to actually do the hosting. And the way we do that is we double click on the button and it brings us to the event procedure for this particular button. Actually, I'll just pretty much right mouse click and say go to definition. Might be an easier way. There's my button click event. Now we're going to need those using statements, of course, because we did set a reference and we are going to exercise the service model code. So let's go ahead now and put that in here. Type in the service model. we're going to now declare an object that will host it. So we're going to go here to the top of my class and type that in super fast. Service host is the object which will allow you to host a WCF service programmatically. Now all we need to do is actually write the code for that over here. So we're going to do that by typing really quickly a bunch of hosting code. Now notice I can programmatically add a bunch of the endpoints as opposed to do it with the configuration file. But we'll do programmatic later today in the advanced section. We're just going to rely on configuration information here. So what I'm going to do now is a little trick here. I'm going to go over and essentially I'm going to move this app config from the service into my host. That way my WPF host can actually know what's going on. So I'm going to pretty much cut this guy out and paste it into my WPF host. Notice it is now gone from here, but it is here. And so my host knows what it needs to expose here just by looking at the app config file. So I think we're ready to go here. I'm going to just right mouse click on the solution and say rebuild solution. Everything seems happy. I'm going to set a breakpoint here so we can actually see this happening. I don't want to pause too long here because then it'll time out on me and then I'll have to restart. So I'll put a little breakpoint here and let's right mouse click and debug this guy. Start the new instance. Nice big button, even I can see that. Hit the F5 key or the F10 key, here we go. Tracing through, opening the service. Typical kind of Windows asking if that's okay. I'm going to say
firewall.
Service is ready. So I'm going to return back to the client at this point. Right mouse click and start it. Let me make sure I have my breakpoint still so we can see it actually run. Yep, I do. So right mouse click and start new instance with the debugger. Click through. And we're good. So it worked just like it did before. If we look here, it did flip the case again. And this time, however, notice we hosted it in a separate process. Again, that was one of the three options, IIS, service, Windows Service, or in a managed application. I chose WPF.
Right.
You probably can't choose a Windows Store app, though. That's not going to work.
No, and that's, I was about to say, really, if you look across those, it really comes down to pretty much most any managed app, except store apps. But so that's you could do them in your WPFs, you could do them in a console app, a WinForm app. You could go on and create a service host with that.
Okay, we got like 4 seconds according to the clock, and guess what, everybody? We made it through the introduction.
No way.
That was good timing.
All right, fantastic. Any other slides on that then?
No, I think we're done for the moment. Did you have
Okay.
your slides you wanted to show?
No, I said at this point, I believe we'll take a break, come back in about 10 minutes, and we'll start up with the next module.
Thanks for being tuned. Don't go away.
See you soon.